Hey there, welcome back to our channel. In today's video, we're going to tackle a common problem faced by electronic enthusiasts: how to find the value of a burnt open-circuit unmarked resistor. It's a scenario that can leave even the most experienced of us scratching our heads. But not to worry, we've got a step-by-step guide to help you navigate this tricky situation with ease. So let's put on our thinking caps, roll up our sleeves, and jump right into it. But worry not, because we've got you covered. Let's jump right in. The first step is to gather the necessary equipment. You'll require a multimeter, a handy device for measuring different aspects of electrical circuits. A power supply can be useful, though it's not essential. A breadboard, while optional, can provide a safe and convenient workspace. Lastly, don't forget a few jumper wires to establish connections. These tools will aid you in finding the value of that burnt open circuit unmarked resistor. Once you have all these, you're ready to proceed. Before we begin testing the resistor, examine it closely for any visible color bands. Often, despite the damage, traces of these bands may remain. These bands denote the resistor's value, tolerance, and sometimes even its temperature coefficient. Now, if you spot any of these color bands, even if they're faded or partially burnt, do take a moment to jot them down. Remember, the color bands are usually read from left to right or from top to bottom. The first two bands represent the first two digits of the resistor's value. The third band signifies the multiplier, while the fourth band, if present, indicates the tolerance. A fifth band, if there, shows the temperature coefficient. Even if they're partially visible, these color bands can provide valuable hints about the original value of the resistor, aiding you in your quest to find its value. Now let's measure the resistance of the burnt resistor using a multimeter. First things first, we need to set up our multimeter. Make sure the multimeter is set to the resistance measurement mode. This is often represented by the Greek letter omega. If your multimeter has an auto-ranging feature, go ahead and enable it. This allows the multimeter to automatically select the appropriate range for the resistance measurement. Next, it's time to connect the multimeter to the resistor. You'll do this using the multimeter's probes. The black probe should be connected to one end of the resistor, while the red probe is connected to the other end. It's important to ensure that the probes have a good solid contact with the resistor's leads. This will help us get an accurate measurement. Now that everything is set up, it's time to observe the multimeter's reading. This is where things can get a little tricky. If the multimeter displays a value close to 0, this could indicate that the resistor is open circuit. This means that there's a break in the circuit, and the current can't flow through the resistor. On the other hand, if the multimeter displays an OL or overload indication, this also signifies an open circuit. Here's where a bit of detective work comes in. If the multimeter does show a value close to 0 or an OL, this means that the resistor is open circuit, and we won't be able to determine its original value directly. But don't get disheartened. Remember, this is just one part of the process, and we have other methods to help us figure out the value of the burnt resistor. So that's how you measure the resistance of a burnt resistor using a multimeter. It's a simple process, but one that requires careful attention to detail. Keep in mind that accurate measurements are key to finding the right resistor value. If the multimeter displays a value close to 0 or an OL, the resistor is open circuit. If you have a power supply, you can perform an additional test to gain more insights. This step is optional, but it can provide valuable information, especially when other methods fall short. Firstly, ensure your power supply is off. Connect one end of the resistor to the positive terminal of the power supply and the other end to the negative terminal. Make sure the connections are secure. Safety is paramount, so don't forget to use gloves and goggles to protect yourself. Now, turn on the power supply and set it to a low voltage, let's say 5 volts. This is to prevent any further damage to the resistor or any other components in the circuit. Gradually increase the voltage while keeping a close eye on the resistor. Observe the resistor's behavior. Does it heat up or emit smoke? If it does, this suggests a short circuit or a damaged component. It's also possible that the resistor might not show any noticeable changes. This is perfectly normal and is often the case with higher value resistors. If your power supply has a current display, take note of the current flowing through the resistor. By applying Ohm's law, you can calculate the resistance of the resistor. Remember, Ohm's law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. The law is usually formulated as V equals 1 times R, where V is the voltage, I is the current, and R is the resistance. So, if you know the voltage you applied and the current flowing through the resistor, you can calculate the resistance by rearranging the formula to R equals V divided by I. This can give you a rough estimate of the resistor's value. Remember, this method is not foolproof. It's a process of trial and error and requires a fair bit of patience. But it's a handy technique to have in your toolkit when you're faced with a burnt, unmarked resistor. The behavior of the resistor can provide clues about its original value. So keep these observations in mind as you continue your investigation and move on to the next steps. Now, let's compare the observed behavior of the burnt resistor with known resistor values. This step is crucial as it begins to bring shape to our investigation. We're essentially playing detective, using the clues we've gathered so far to make an educated guess about the value of the resistor. First, consider any color bands you may have identified. These bands can tell us a lot about a resistor's value. If you've been able to decipher any of these, they can provide a starting point for our range of potential values. Then, think about the behavior of the resistor when we applied voltage. Did it heat up? Did it smoke? These signs can also give us hints about its original value. Finally, consider the circuit itself. What role does this resistor play in the overall circuit? Could it be a pull-up or pull-down resistor, or perhaps it's part of a voltage divider? Reflecting on these questions can provide additional insight. This comparison can help narrow down the range of possible resistor values. To narrow down the possibilities, you can test different resistors of known values in place of the burnt one. This step is where your detective skills truly come into play, as you'll be seeking to replicate the original behavior of the circuit. Begin by selecting a resistor with the lowest possible value you estimated earlier. If you're unsure, you can start with a very low value, such as 1 ohm. Connect this resistor to the circuit where the original resistor was located. Be sure to observe all safety precautions while doing this, as you don't want to risk further damage to the circuit or indeed to yourself. Next, power up the circuit and observe its behavior. If the circuit behaves as expected, congratulations, you've likely found the original value of the burnt resistor. If not, don't be disheartened. It's time to try a resistor with a slightly higher value. Turn off the power, replace the resistor with one of a higher value, and repeat the process. As you incrementally increase the value of the resistor, keep a keen eye on the circuit's behavior. You're looking for the point where the circuit starts behaving as it originally did. Remember, the goal here is not to find the exact value of the burnt resistor, but to identify a value that allows the circuit to operate as intended. This process is a bit like solving a puzzle, and it requires patience and a systematic approach. As you test different resistors, make notes of the circuit's behavior with each one. This can help you identify patterns and narrow down the most likely values of the original resistor. If you have a broad range of resistors at your disposal, you can fine-tune your search even further. Testing different resistors will help you find the closest match to the burnt one. This method might not give you the exact value of the original resistor, but it will give you a workable solution to get your circuit up and running again. And there you have it. We've journeyed together through the process of identifying the value of a burnt open circuit unmarked resistor, starting from gathering the necessary equipment, checking for visible color bands, measuring resistance with a multimeter, and potentially using a power supply for additional insights. We compared observed behavior with known resistor values and tested potential resistor values. In some cases, we may also need to replace and retest the resistor. It's important to note that this process requires patience and sometimes a bit of trial and error, but with perseverance, you'll get there. We hope this video was helpful to you. If you have any questions or suggestions for future videos, please let us know in the comments below. Don't forget to like and subscribe to our channel for more informative content. Until next time.